Stoichiometry is a rather challenging topic to teach. Anytime you start with the mole concept, many times students will either embrace that if they're very strong with math, so they may mathematically get problems right, and students with weaker math backgrounds can really struggle because stoichiometry ties a number of concepts together in a way that can be very abstract for many students as they solve multi-step math type of problems. Many stoichiometry experiments are difficult. There's a lot going on. This experiment, the thermal decomposition of baking soda, has a number of advantages, and I'd like to perform that today. What I have in here would be 2.00 grams of baking soda. I've weighed that out, just Arm & Hammer baking soda, found at the grocery store. This is a lifetime supply for this experiment, this size container. I have a metal crucible here, and what I like about this one is it's got a nice flat bottom, so it sets nicely on that. So I'm going to put the baking soda in there, and you can also perform this experiment, and I'll show you that as well, inside a test tube, just a standard Pyrex type of test tube. 2.00 grams of baking soda also going in. And what I try to do is spread the baking soda across the bottom several centimeters across, like that. Okay, I'll turn on the Bunsen burners. Get that going. And what we can already see here is the formation of water. That you see the water droplets appearing near the mouth of the test tube. That's one advantage of using the test tube over the metal crucible. What I like about the crucible, though, is if you look down in, you're able to see with the two metal spatulas as it heats up. Now let that do its thing. You can see again the formation of water out here. And so while that's going, I'd like to go over to the board now and talk a little bit about what the chemistry is. Oftentimes, we'll tell the students exactly what's going on in the chemistry. We want them to know as a class. This experiment allows us to present chemistry as a problem-solving exercise. Here we shift the focus from doing just straight stoichiometry type of problems into an authentic problem where they're using stoichiometry, applying their knowledge to solve a real-life problem. There are three possible decomposition reactions that could be occurring inside the crucible or the test tube at this point. One would have the baking soda, the sodium bicarbonate, decomposing to produce sodium hydroxide and releasing carbon dioxide gas. A second possible reaction would have the baking soda producing sodium oxide as well as carbon dioxide and water vapor. The last possible equation, which could be occurring, would have us starting with our baking soda and producing sodium carbonate along with carbon dioxide and water vapor. You'll notice that I've indicated that solid, gas. I want my students to focus on the experiment and really try to minimize any chance at confusion. Okay? let's head over and take another look here. It's still a white solid, okay? So there's still white solid remaining. Here in our test tube, we've essentially driven off most of the water. We can heat that up. In fact, I think that one is done. This one, go ahead and power this down as well. Visually, this is not the most exciting chemistry that your students will see. But what we've done, if you think about it, we've already done the experiment. There's very little chance to have a lab mistake. Assuming they get the baking soda inside the crucible, assuming that they use the balance properly, there's very little that can go wrong here in terms of student error. Now, what we do, we always follow the safe policy of never putting something too hot for your hand on the balance. With the metal crucible, what I'm going to do is I'm going to pick that up, and I've got a wet paper towel here. A wet paper towel, since it's a metal crucible, we would never want to try this with the ceramic crucibles. But that water, the high specific heat capacity of the water will really draw the heat energy away from the metal crucible. Now, if we can go back to the equations, because the experiment is incredibly simple. Weigh out some baking soda, heat it up, let it cool down. As we look here, and hopefully this is obvious to our students, we heated up a solid. Well, we know that what's left inside the crucible right now is also a solid. And so what that should tell us, by having solid, gas, solid, gas, gas, solid, gas, gas, having those phases literally written out, not just S or G in my case, because I'll have students say, well, what does G stand for? By writing out the whole word, we can hopefully minimize any confusion that the students have. Knowing that I have started with a solid and I'm producing a solid, that allows me to say the gas, or the gases, are going to be lost to the air inside our classroom. What we would have left over would be the solid. So it'll either be the solid sodium hydroxide, the solid sodium oxide, or the solid sodium carbonate. And their job is to use stoichiometry to determine, was it this reaction, or this reaction? And presenting it in this way really forces our students to go beyond worksheets where they may solve problem number 1, problem number 2, problem number 3 into a real-life situation. All three reactions certainly involve known substances. We're not producing a mystery type of chemical. They all appear very, very logical as to what could be happening. And it's their job to determine, use your stoichiometry skills to answer the question. Was it reaction number 1, reaction number 2, or reaction number 3? Okay. Okay, this is not quite cooled down yet, but if we look, if we do the stoichiometry, what we find we should produce from 2.00 grams of the baking soda, we should produce 0.952 grams of the sodium hydroxide using our stoichiometry. 2.000 grams, 2.00 grams of the baking soda here will produce approximately 0.738 grams of the solid sodium oxide, if that's the right reaction. The third possible decomposition reaction, if I start again with 2.00 grams, is expected to produce approximately 1.26 grams of the solid sodium carbonate. Okay? So again, we see 2 grams will produce about 0.95 grams to 2 decimal places. 2.00 here, 0.9 or 0.74, 2.00 about 1.26. 3 distinctly different masses, and we can use our stoichiometry to find out, is it reaction 1, reaction 2, or reaction 3. We've got our balance zeroed. Crucible has cooled down, and we're going to find out in real time which of the 3 possible reactions. Here we go. $1.24